Good afternoon. Sorry for not presenting in person due to the outbreak of the virus. My name is Heng Cheng. Today I'm going to present this paper with my partner Zhao Xu, and we are undergraduate students from the Southern University of Science and Technology. As you can see from the title, it is about an empirical study on the API evolution in Python libraries. There are lots of works studying the API evolution in frameworks and platforms that use Java, C, and C++. They study the breaking changes made to the APIs, characterizing the compatibility issues, and help developers migrate their code to the new library release. When we start working on this project, we are asked by our lab mates, why do we work on this? There are lots of works studying this problem. And I showed him this picture on Reddit. As a dynamic programming language, Python is different from Java. First, there's a little type annotation in Python code since it is dynamically typed. In this case, when the library developer changes the type of a parameter, client developer will not know such changes until she reads the document. Second, Python code is executed directly by an interpreter, so there is no compile time type checking. When someone uses a string as the index of an array, it will cause a runtime exception instead of a compile time error. Furthermore, when calling a Python function, one can pass positional arguments and keyword arguments. Some of them are optional if they have default values. So there are lots of ways can library developer change the signature of a function, and it is more likely to cause compatibility issues. In practice, there are lots of issues in Python caused by such language features, and they result in different types of runtime exceptions. These are examples on Stack Overflow. Here, the unexpected keyword arguments are due to parameter changes, and the attribute error is due to API relocation. So, in this paper, we aim to answer these questions. How do Python framework APIs evolve? Are they different from that in Java? What are the compatibility issues? And how do developers fix these issues? To answer these questions, we need to analyze a large number of real-world projects that use Python frameworks. We first selected some popular frameworks from different categories, like TensorFlow, Keras, sklearn, Pandas, Flask, and Django. And then we search for projects that use these frameworks on GitHub based on their popularities. We took the top 1,000 projects from each search. But here the sklearn has only 883 projects, so we took all of them. To summarize, our subjects contains 6 frameworks from 3 different categories, and totally over 200 releases and over 5,000 open source projects. We install the releases in Docker containers and extract the APIs that expose dynamically by reflection. We didn't use static analysis because developers often assign a long API name to a short one. For example, in TensorFlow, tf.concat, it is used to connect 2 tensors. This API is mapped from tensorflow.python.something. It is a very long name. We extract the APIs dynamically in order not to miss these short names. After extraction, we classified over 1 million API changes into 14 categories by their syntactical differences. In order to find the compatibility issues and their fixes, we collected the issue reports and commits from the over 5,000 GitHub projects. We took the commits into account because lots of compatibility issues are fixed before being reported, but we didn't want to miss them. After random sampling and manual analysis, we got a corpus of over 400 issues and over 300 of them has a fix. This is table 2 in the paper, and it shows the 14 types of API evolution patterns. 9 of them are also observed in a recent study on the API evolution in Java, and 5 of them are observed in Python. We further classified them into breaking changes and non-breaking changes in order to make a comparison with them in Java. According to a recent study, 28% of the API changes in Java are breaking, and these breaking changes impacted only 2.5% of the client applications. However, in Python, over half of the API changes are breaking, and these changes impacted 53% of the clients. On the right side, for classes, methods, and fields, breaking changes happen more frequently in Python. These rates are much higher than that in Java, indicating the compatibility issue in Python is more severe. By looking how these evolution patterns distribute, we find that most of them are API addition and removal. Only 4% are related to parameter changes, but there are 8 different patterns in it. Next, my partner Zhao Xu will introduce these patterns and the compatibility issues they cause in detail.
Well, thanks Heng Cheng, and good afternoon everyone. I am Zhao Xu. In the following, I'm going to use 2 real-world examples to show how Python framework API evolutions affect real-world client and how developers react to them. The first example comes from a project called Pandas Table. When users run this project on Pandas 0.24, it throws a module not found error. This is one kind of import error. The reason is that the plotting is no longer under the module Pandas tools, and also the tools doesn't exist anymore. Actually, in the 0.20 version, the plotting is copied to the Pandas module, and then in the 0.24 version, the old API finally removed. As a whole result, the original API actually went through a relocation process. Then, if you still import this API like this, it would throw an import error. And then, if you use it directly like this one, it would throw an attribute error. Here is another example from project Colonet. When the client ran this code on the TensorFlow 1.0, they got a type error. Obviously, the type error means the type of your passed argument is not correct. Actually, the reason for this crash is that the tf.concat API experienced a breaking change from the version 0.12 to version 1.0. Although the name of this API isn't changed, but the parameter does change. Firstly, the values parameter is exchanged with the concat dim, and then the concat dim is renamed to axis. Therefore, if you still use the API like this, you pass the argument to use the positional argument, a type error will happen. In our study, we found that instead of directly replacing the old APIs with new ones, developers adopt some common strategies to fix these issues. To fix the last kind of issue we just mentioned, developers would try to alternate the way they pass the argument. For example, they would change to the keyword argument if the parameter is reordered in the new version, because the keyword passing will not be affected by the sequence of the parameter. And otherwise, if the parameter is renamed in the new version, they would try to use the positional argument, as in this way, it won't be affected by the parameter name. Other two fixes strategies can be applied to all kinds of API changes. For example, by catching the exceptions thrown by the API incompatibility, developers can use the alternative APIs in the catching block. Or by checking the API existence or API versions, developers can directly choose correct APIs for use. Before we start the next part, which would be a tool we developed based on our empirical study, we provided a brief conclusion here for our empirical study. Actually, we performed the first study on Python framework API's evolution. In detail, we identified 14 evolution patterns with 5 specific to Python. And also we found 3 major exceptions resulted from these evolutions and 4 fixing strategies that developers commonly adopted. In the following, I am going to introduce the compatibility issue detectors we designed for our project, PyCompat. PyCompat would extract the API knowledge base from the library releases semi-automatically. The API knowledge base basically encrypts the evolution process of an API, and then PyCompat would perform the compatibility checking on each Python source code and throw a warning if there is a potential issue. So how does our tool works? As the example shows here, suppose we have already got the following knowledge base and want to check the code snippets on the right hand side. In the knowledge base, we have 2 APIs evolutions. The first one is a renamed API, which is tf.pack. It is renamed to tf.stack. And the other one is an API with parameter renamed. The shape parameter is renamed to dense shape. PyCompat would first go along the abstract syntax tree of the code and check each API call site. When it reached line 4, it would find an API call to tf.stack, which is an involved API in our knowledge base. Then PyCompat would check the first kind of issue here, called ARR. This issue is induced by using APIs that has been renamed before. It would then perform a backward slicing to the up layer of this line and check if there is any necessary protection code we have found it before. For this API call, it has an if statement here to check the API existence. Therefore, PyCompat will not throw any warning here. Then it would perform a similar check to the following API call site and then record the result in the left table. It would go along the abstract syntax tree until it found the API call to tf.sparseTensor. It would check another issue here called PRN to check the usage of an API that had a renamed parameter. If the client used the keyword to pass the value for this parameter, it would crash on another version because the name is not the same. PyCompat would perform a similar backward slicing here to check the protection code, but unfortunately it cannot find any protection code here, and then it will throw a warning here. To see how our tool works, we made an experiment on 10 projects from GitHub. These projects vary in their size and lines of code. We did experiments on the latest version of their code. PyCompat totally identified 231 dangerous points in their code, and we summarized them into 13 issue reports and feedback to the developers. Finally, we got 7 developers confirmed our reports, and some of them even quickly fixed their code. And for another 3 of them, they are reluctant to confirm that. This is mainly because that they don't want their code to be compatible on 2 old versions of the frameworks. Last but not the least, our work is still an initial work of Python framework API's evolutions. There are still many other works on this topic. For example, we can fully automate our tool PyCompat by automating the API knowledge base extraction process. We can also propose some patches to the compatibility issues we found. This would be very challenging considering the code style of the original project. Also, it would be very interesting to investigate the API evolutions of other dynamic programming languages frameworks. Well, thanks for listening our presentation and hope you all have a good day.